and we'll work on it some more on the next class period also. But yeah, it's used when you have to find the derivative of a composite function, like y equals f of g of x, something like that. Okay, so to find the derivative of this, it's kind of interesting because you kind of have like this inside part, you know, like this g of x is like this inside part. So to find the derivative of this, to find like y prime, they say it's like the derivative of the outside, f prime of g of x, then times the derivative of g of x. Okay, so you're given a composite function here, composite function, and so then, yeah, the derivative, they would do it like that. To find the derivative of this, they do f prime of g of x times the derivative of g of x. So sometimes this inside part, this g of x, this inside part, they label it, they sometimes use the letter u, and I don't know why they picked the letter u, but they did, and sometimes they label this inside part with letter u, and I'll show you one of these. I'll show you how this works. So let's say we had y equals 2x squared plus 5 to the third power. So this inside part, see, that's like another function inside something to the third power. This inside part, they label that with a letter u sometimes. So then they would say it's like you have something here, you know, it's like something in here, a bunch of stuff in here to the third power. So they might rewrite it like u to the third power. Just to simplify it for a second so you can see it. See, it's like something to the third power, then plus we have this inside stuff. So sometimes off to the side, it helps people to write, well, the u, all this inside stuff is 2x squared plus 5. You know, that's this inside stuff. So it's this u stuff to the third power. So like we're saying, like they're saying here, you have to figure out first, like the derivative, like this, when you have something to the third power, we've done that power rule on it. So you have to find the derivative of this, and then times it by the derivative of the inside stuff. See, like times the derivative of this u stuff. We're calling this g of x part like u. Like this inside stuff, like u. So it is kind of tricky. So they say you have to find like the derivative of u. Like what's u prime? What's the derivative of this inside stuff? Yeah, it'd be 4x. All right, so they tell you that you can do the power rule on this. So if we want to find the derivative, y prime, you take the derivative of this u to the third power. So remember how that power rule works? You like bring this over. So it'd be 3u squared. And then like we said up here, it's like doing the derivative of this function to the third power. Then you're going to times it by g prime or u. Then it's like the derivative of u. Then like what's the derivative of that inside stuff? So some people do it like this way off to the side, because it simplifies it into something easy. So I know it's just going to be 3 times my function squared, and then times the derivative of that function that was inside. So now I can put back what u was. You know, this is basically the answer, but now you could just substitute back in. So now I know what u was. So, you know, like substitute, and I know the u prime, I know what that was. That's why people do it off to the side. U, they define what u is, and then the derivative of u, because then they can plug it back in at the end and have the answer. It'd be 3, and then u was this 2x squared plus 5 squared. And then u prime, you guys said that was 4x So it'd be like times 4x. So you could clean this up a little bit. You could put the 3 and the 4x together. So the final answer would be 12x times 2x squared plus 5 squared. That'd be the answer. So what do you think of that? I mean, I don't always have to write the u stuff on the side. Like sometimes I can just look at it and I'm like, okay, I got to do 3 and then this to the second power and then the derivative of that stuff inside. Sometimes writing this is helpful when they get really complicated problems. You don't always have to separately define the u off to the side. It just helps sometimes as they get more complicated. So we'll try. It helps when they get more difficult. Okay, so we'll try another one so you just can kind of see it, how this chain rule works. Here, this paper's more blank so you can see better. Okay, so let's try another one. And this applies to trig functions too, so you'll see. So let's try another one. So if it's like y equals the square root of 3x squared minus x plus 1. So see, it's like all this stuff inside of here, you could say that's u. U equals 3x squared minus x plus 1, if that helps you to write that off to the side. So really this problem is like all that stuff could be defined as u off to the side. So it's really just like square root of something, right? Square root of some things. See, so it's the same as like u to the 1/2 power, right? Like something to some stuff to the 1/2 power. So to do the derivative of this, if you think of it this way, see, it's a lot easier, and then you can plug back in what u equaled at the end. What do you think of that? So to do the derivative of this, you do bring the 1/2 in the front, 1/2 u to the, then remember you subtract 1 from this, so it'd be negative 1/2 power. You know, 1/2 minus 1 is negative 1/2. And then you have to times it by u prime at the end. You're going to have to keep remembering at the end, then you times by the derivative of that inside stuff, of the u stuff. So up here too, you're going to have to find the derivative of u. So what's the derivative of this inside stuff, that g of x function that was inside? Yeah, 6x minus 1. So we basically have the answer right here. We just have to plug back in what u equaled and what u prime equals, and then we have it. What do you think? It's not too bad if you get used to it. So it's 1/2. And it's u to the negative 1/2, so remember that'll be like in the denominator. You can move that to the denominator. It'd be like u to the 1/2 down here. And the u prime would be up here. It's really like that. 1/2, you know, it's like going to be like a fraction. And this u to the negative 1/2 power, negative powers go to the denominator, right? And the top's u prime. It's not a 1, it's a u prime. Now let's plug back in what all our stuff was. So my answer is going to be, the u prime stuff is 6x minus 1. And the bottom part's going to be 2 square root, 1/2 power is like square root of all the u stuff again. 3x squared minus x plus 1. See, that's the answer. So it is helpful to do the u and the u prime off to the side sometimes. Some people can see it without doing this. Like I see it's something to the 1/2 power. So it's 1/2 power, or it's 1/2 times this to the negative 1/2 power times the derivative of that. Yeah, chain rule. Okay, now this also applies to different trig functions and stuff.
So, like, you only use the chain rule when, like, the whole function is to the power of something.
Yep, because you'll do the the power rule, bring the power in front, subtract 1 from the power, and then it's times the derivative of the inside parentheses stuff. Yep. Okay, let's try another one. Let's say you had y equals cosine of 4x squared. So, cosine of this. Let's try a trig one. So, this part inside is like u. So, u equals 4x squared. See, it's like f of x is cosine and g of x is 4x squared. Yeah, so cosine of 4x squared. So what's the derivative of cosine? Yeah, so it's going to be negative sine. You don't have to do it with u. I mean, I'm just trying to label it for you. I could do it both ways. Like, I think of it as cosine of this, and then I'll times it by the derivative of that. It's not too bad. You can do it off to the side. So it's going to be like sine of this stuff, this u stuff, and then times the derivative of u. And so we said this u stuff was 4x squared. So it's still sine of 4x squared, negative sine 4x squared. But then you have to times by the derivative of this u stuff. So what's the derivative of u? Yeah, so it'll be times 8x. So I'll just write it here. U prime equals 8x. Good job. So this is going to be times 8x at the end. So it'll be negative, 4x. Negative 8x sine of 4x squared. Yep, that's my derivative. Yeah, it's the chain rule. Sometimes you have to apply the chain rule several times. Yeah, because it's just multiply. I know, because otherwise it looks like, I don't know, it almost looks like that, Yeah, it's the same thing. They just usually write. Yeah. Now let's try a different one. This one's kind of different. Let's try y equals tangent squared x. This one's kind of different. Yeah, it's not too bad. It just takes some getting used to. So this one's kind of different. What do you think u is this time?
X.
No. Closer, but not quite. What about u just as being in tangent? Because isn't it just like something squared? Like, could you just think of this as something, like the tangent is the u, so it's just like tangent squared, like something squared, u squared? See, this is kind of weird to think about, isn't it? You have to decide what u equals. And this one's kind of different because it's like something to the second power. So the tangent is that something. It is kind of weird. So it's just something to a power. Because we don't know the derivative of tangent squared. We just know derivative of plain old tangent. Yeah, we just know derivative of just tangent. So you have to do your power rule to find the derivative. You bring the second power to the front. So it'll be 2u to the first power, and then times the derivative of u. Well, we know what u was. In our problem, we were saying u is tangent. So now it's like 2 tangent x. But what's the derivative of this u? U is tangent. So what's the derivative of that? What's the derivative of tangent? So see, at the end, I'm putting like tangent back in for this u. Yeah, secant squared. So the u prime part, we're going to plug in secant squared x. That's the answer then. 2 tangent squared secant squared, or 2 tangent x secant squared x. Kind of weird, isn't it? That one's kind of different because you had to make the trig function the u part. It'd be the same if it was like tangent to the third power or you know, something like sine to the fourth power or something. Yeah, you'd have to make the trig thing the u part. So it does help putting the u part off to the side to decide how you're going to define these things. Yeah, that's the gist of it. That's the gist of this chain rule. So we'll try some of these. I'll pause the video. So we're going to take our B. Yeah, so the BME, it's on the computer. The password's the word quotient. And you, some of you said you were looking at it already. Yeah, that's fine because you thought with MVP and stuff. Yeah, and some people have 2 math classes and you might have took it in another math class. That's, you know, but it shouldn't be too bad. The BME is kind of like a progress report type thing. Measures, you can see how you did on the one at the beginning of the year and then how you do on this one now. You can kind of compare.
I got 1 point less.
I got
1
1.
point less?
More.
1 point more? That's good.
Will this affect my grade?
1 point more?
Because 17 to an 18.
Yeah, some people get about the same, or 1 point more, or 1 point less. Hopefully you do about the same as the first time. Yeah, because it's over, like, it has like some geometry and algebra 2 questions in it.
And a stats question.
Yeah, I did too.
Oh, yeah.
Does
So-
this affect my grade?
Yes.
No, it doesn't. It's like a progress report type thing for the district. And then you could start trying these chain rule after you're done. They are kind of tricky. You really got to think about it. If you need help like deciding what U is,
Yeah, I just.
that's the hard part sometimes.
So like, here, you just take all that, that's here.
Yeah, so it's like
Here, we just take.
the
Why
inside.
did we take the derivative of sine? Why is it just the inside? Why
We
is
took
sine-
the derivative of cosine, because that's like the f of x part, and this is the g of x part. See, it's like you have f
Oh, so
of
this is
g of x.
G of x. There's no f of x.
F of x is like something to the third power. It's like the f of x part is like something to the third power. The g of x part is the 2x squared plus 5.
You want to spell quotient?
The f of x part is like cosine of something, and the g of x part is 4x squared.
Like, if it was just cosine of 4x, then we just say
No, you'd still have to use chain rule. It'd be negative sine 4x and then times 4, because then it'd be times the inside part, the derivative of the inside part. So like,
Can I get this off? Because like, it's so weird.
Good idea, Connie. Good idea.
yeah, like, okay, maybe writing it off to the side or something. It's like the f of x part. Okay, so it's like the f of x part is just like a cosine of something, and the g of x part is the 4x squared.
So why?
So it's f of, you know, it's like f of g of x where like that's put in there. It's a composite function, how it's written. It's a cosine of a bunch of things. Like this is like, yeah, it's like, I don't know how to write it. F of x is cosine of something. Okay, like it's like, I could rewrite it. It's like y equals, it's like cosine of u. And the
That's what I
u,
was gonna do.
I've been going to one.
and then so y prime, you would take the derivative of cosine, which would be sine of, negative sine of u times the u prime. And so then u is the 4x squared, and the derivative of that is 8x.
No, that should be it.
Okay, I get it.
I did write this down. Yeah, I skipped this step.
No, I wrote
Because I
that
can
stuff
see them in my head sometimes.
I
like-
just wrote that stuff wrong.
Oh, that's okay. It's
Oh
kind
my
of tricky,
god,
I know.
I'm sorry, not loud.
Oh, you're okay.
I mean, that's out of pocket for rear-ending someone.
Yeah, so these are kind of tough. Like, I mean, it's just like multi-step. It's like derivative of the inside of
My
Oh, yeah.
studies does not give me enough
Oh, yeah,
information
this
to
is
figure this out.
What the hell? My mom's gonna be so mad.
Or do I just equal that to zero?
Yeah.
Oh, I meant to
And
do
their
that.
insurance company keeps calling me.
Like, I wrote down.
Everything. They had 0 units for their car, and they still were going.
Okay, like I wrote them down in this notebook too, because I like to work them out too, because then I kind of see like where people might run into trouble, you know, on things.
And then
Because I like make little notes to myself, like when I did 83, I had this, and then I looked at the answer key, and it's like, oh, then they just did common denominator then, you know, it's like, Or one of these up here, I had this, and then I looked at the answer again, and then they factored out a secant. You know, it's like, oh, it's pretty much the same. So you're saying 85, you didn't have to do 85. It was like 83 and 84. Oh, it's okay. It's 83, 84, and 86. It's okay. Yeah, that's fine. You're getting it. It's so yeah. Now that we're gonna do hybrid, I kind of just like, okay, what are we gonna do? So we have, like, I'm gonna see you guys. I was like thinking in my head, like, when am I gonna see everybody then? So today's Wednesday, so I'll see you Friday, and then I'll see you Tuesday, and then I'll see you the first week we come back once. See, and then I'll just see you the second week once. Because when they do this hybrid, it's gonna be like A day, or like B day, A day, A day, or something. I don't know how they're gonna do it.
Yeah.
Do you think it's gonna go like A day, B day, because it's only half the alphabet, half the alphabet, so I'm only gonna see you once a week. And then, so when we come back, we're just gonna have to review the first time you come back, and then test the next week. I know, so it's gonna be, but our semester test, I put a little note on the board, so it's gonna be that second week of January, and it'll be over chapter 1, the limit stuff, but I have some reviews on it, and then what we've learned in chapter 2 so far. We're not even done with chapter 2, but it'll just be over what we have in chapter 2 so far, up through this chain rule. Yeah, the last 2 sections in chapter 2 we'll do after when the new semester starts.
This is ridiculous.
It'll work out. I know. I'll be. Yeah, so like I was saying, the U stuff can be helpful. Sometimes I can do it without writing out what U equals every time. Like this one, I can see it, like I'm just gonna pull the 3 in the front and do like 3 times this to the second power, and then it'll be times the derivative of this inside stuff. You kind of get what I'm saying? Because it's like a bunch of stuff to the 3rd power. Yeah, so like I can do it without even writing what U equals off to the side sometimes. Like I just know this 3 will go in front, 3 times all this to the 2nd power, because it goes down a power, times the inside stuff, which the derivative of this was 2. So if you can do, then you can just do 2 times 3 is 6, so it's 6 times this squared, and then you're done. Yeah, it's not too bad once you get the idea of it. Sometimes it's really helpful to write what U equals off to the side, because some of them get really complicated. And sometimes you can just do it by looking at it. Yeah. Like the U would be all, yeah, so all this inside stuff is like U. So it's like something to the 2/3 power. And so you can just think of it as U to the 2/3 power and do the derivative of that. But then at the end, just remember, then you have to times by the derivative of the inside stuff.
Wait, okay.
I know, it's weird. Hello.
It's just the derivative of the subfunction in the equation.
That's right, we're doing calculus.
Oh God.
How are you doing?
Good, you see.
We could probably find something.
If not, I mean,
Just fraction work.
yeah,
just
fraction
like
work, because you know our kids struggle with that.
Yeah, like math and fraction multiply divided.
And on the computer, you know, they're not good at scratch paper.
Oh,
If I could do a handout to them.
man, it's been a while. Let's see what I got. Well, I might have some old stuff, because like now I'm teaching algebra too, so I have some old stuff back in here. Like I had 4-game, 1-step equations, 2-step equations. Yeah, punchline, 1-step equations.
I don't understand.
Little
Yes.
2-step equations.
Yeah, that's hard.
I actually did it.
That's a fraction, did it?
Because I
Yeah, that's why I thought we should fraction work, and then these would be good.
Like I hate
Yeah, I have some old things. You just have to dig through things.
If I would have like used soda math,
Some 1-step multiply divide.
There would have been a whole course.
I know, these are all just old.
Yeah,
I saved everything.
I'm
I
not
know.
gonna solve them. I think I'm just gonna
More 2-step equations. I don't know if you want all this.
No, that's
No,
not.
I don't have
It's
it.
from our old
So
algebra.
let's see here. This one's 1 step. These are 2.
So, Yeah, that's two
The
steps.
first time I did it,
I could dig and
top
maybe some
left.
stuff
Take
for
your time.
fractions.
How to do it.
Yeah, you're over it by
Perfect, take your time, no rush at all.
Yeah, no
I'll make
problem.
the copies.
Yeah, sounds good.
Thank you, that way I'll just, we're doing this up on the computer, IXL does something, but
Yeah.
they need extra practice.
Yeah, that sounds good.
Thank you.
Yeah, no problem.
There was so many questions on that last ACT about ellipses.
So he wants some
And I was like,
fraction
I don't know what
stuff.
that is.
Right,
But I know
fractions
it's-
is
It's like
decimals,
a
that's
graph,
one.
but like an oval instead of a circle. I don't even know.
Oh, no, thank you.
That's alright.
But I know for a fact I failed that
Yeah.
ACT.
Did you take one last weekend?
Yes.
I went to it, but I didn't take it. They wouldn't let me in the door.
Why not?
Oh, because I went there and this lady was sitting at, I took the one in Sergeant Bluff. Okay, of course, I realized that when I left my ID, my whole lanyard in my locker, I was like, oh, I don't have an ID. Like, can I still take pictures? I was like, no, like, it's at work. Like, I don't have an ID. She's like, you have a student? I was like, no, I don't have anything. And it was like, I was like, we went to Iowa this year. She's like, but you went to Iowa, so get it. Anything like this close, like it's too early. She would not let me in the door, so I wasted $55. I know. And I was so mad, because this was the last time I came on TV. Especially for like a ton of like scholarships and stuff. I walked past my car, bawled my eyes out. I would cry. I had the worst week last week ever. I'm just costing my parents money at this point. Like $55 for ACT, $170 ticket, $1,000, whatever.
And the radius of the circle axis is
I'm just costing my parents money.
How do you rewrite the ones that are radical?
You only go once.
So I found some stuff for him.
1/2
I found a whole bunch of old fraction stuff from like pre-algebra.
Okay, how do you write the radical? How do you rewrite it?
Okay,
I
so
feel like you didn't
nine.
No.
why do you want to go there?
So
Heck, you sound so upset.
Alright,
yeah,
there
like
we go.
right now that's like u to the 1/3 power. Yeah, so it'd be 1/3 u to the negative a third. No wait, negative 2/3 because it's like 1/3 minus 1, so it's negative 2/3. And then you times it by the derivative of the u part inside. I know it's weird, isn't it? Yeah. And then then it's just times the derivative of this inside stuff because that's the u stuff. Yeah, times 12x. So the negative power, this whole part goes to the bottom of the fraction. And the 3 will be in the bottom of the fraction too because it's 1/3, you know, with 1/3.
I want to be a part of the junior ROTC program.
Yeah, it's weird, isn't it? And then 9, you can do 9 times 2, so it'll be 18 on the top. Yeah. So yeah, it's just kind of simplifying. And then 18 actually divides by 3, so you could get rid of that 3 and simplify it 6 over that stuff, and then you're done. Yeah? Yeah, that's good. Uh-huh.
Did you tell him what the bar is?
Oh yeah, I found stuff for him. Addition and subtraction. He wanted fraction work.
Wait, what is the... I'm doing my name over.
Addition and subtraction of unlike fractions. This is
Whatever.
add and subtract like fractions. That one.
What math is that for?
He has like the low, probably the lowest one in school, and that's fine though. It's practice on that.
That's what I hate.
He has like a special ed math class, like the little kid. That's okay. He's looking for stuff for them to do. Practice. He has stuff on IXL on the computer.
Great.
I've had you guys do IXL before, but you only get like 10 questions and it stops. They have like a subscription to it for the lower kids, and they can work a lot on
Is that what it's
middle school. Yeah, they're probably still like on middle school math stuff, but that's fine. They can work like until they get like 80% on something and go to the next skill. Yeah.
You scared the shit out of me.
So this one is 4 minus 5.
Say
So
the mean number.
well, I just know what U is. Minus PT.
Okay,
Are you
so
sure?
oh, this number 18.
Yeah.
The whole denominator could be the U part. It could be like
Okay.
1 over U.
It'd be like
Yeah, the whole bottom part could be U.
Well,
I know, it's weird, isn't it?
no, I was gonna say
What's the
maybe.
June?
So if it's like 1 over U, like 1 over all this stuff, like 1 over U, so it's really, you could write it as U to the negative 1 power. You know what I mean? So then you could do the derivative of that. Adding and subtracting like fractions. Adding and subtracting like fractions. So I put some stuff together for him. And then this one's unlike fractions.
Well,
Find the common denominator.
Or are not.
Me?
your
Like fractions.
yeah, because you have that down.
Oh wait, no, it's saying you're so I guess so. I'm just like doing it.
Okay, well, I need to know this.
Subtraction of unlike fractions.
Okay.
You put it in wrong.
You might need multiply and divide fractions too. Okay, so the whole bottom part could be U. It could be like 1 over U.
He was from his basketball
Okay,
game.
so U's.
So it's
I
kind of like
write my
people-
U's first.
Yeah, that's fine.
Which one was it? It was your
So it's like 1 over U.
Nine.
She was like,
Oh,
something
1
was
over.
Grace.
Yeah, like the. Well, no, you could leave. U could be the. Okay, U could be what you had. You could do that. But I'm saying like when you rewrite this problem, it's like 1 over U. Yeah.
Yeah.
That's
Okay.
U.
I did better.
Prime would be
I got 16.
They did so bad. The
Yeah.
boys did pretty good though.
Y.
Yeah.
Good job.
1 over U.
The girls are really bad.
Which is the same as like.
Prime would be 1 over U.
I'm gonna do my physics part first.
You also would very simple.
Not quite.
Those are very simple.
You have to take the derivative of the 1 over
I
U.
did not. It's about Benson Jackson.
Like, okay, like here, you did 1 third and you took the derivative.
I
You
love
did
her.
1 third, you did
I was
negative
talking.
2
We were
thirds.
talking about.
You know, 1 over U is the same as U to the negative 1 power, right? And then you have to take the derivative of that U to the negative 1
I was
power.
like,
Yeah, negative 1 U to the
That was
negative 2.
really cool.
And then U prime, yeah.
Okay.
Now you can plug back in what U was and the U prime. Yep. Good job, you're getting that. Okay, so this is add and subtract. Now you can multiply back. Fractions, fractions.
So did you do 21?
No, not yet.
I got it.
They did it on
My grams gonna be 14.
I think I'm gonna join you.
A mass of.
I hate when they use T.
I know, is it plus or is it a T? So when you get first 18 for your final.
I don't even know what to write. Go to the bottom.
Yeah, you know.
It doesn't show
Right,
the
well,
bottom.
I never
Oh
did it.
no.
T squared all
I don't know, because
Yeah,
I
you just
every birthday.
I kind of like this.
And it really
Yeah.
was negative. Why do you put your mom so bad?
Number 12. Oh my gosh.
I write my U's down first.
Yeah.
So let's see. You're 12th. You're already 12th grade, right?
Yeah.
Because I know I have a few sophomores in here and stuff.